Okay, so we're going to examine this phase structure grammar. This is number 5 in section 13.1. And we're given some productions, and the first part is showing that 10101 belongs to the language that's generated by these productions, and 10110 does not belong to the language. Okay, so first, what I'm going to do is, since green starts with a 1, we're going to use this production first. Okay, so we always start with the starting symbol, and then we're going to go to 1A. Now, the next bit is a 0, so I can use this production where A goes to 0B. And then I need a 1, and B goes, but we don't finish at 1, so I need to use this production, not this production. Okay, so we're going to go 101A, and then we're going to use this production to get 1010B, and we're going to finish with this terminal production, which is going to be 10101 as desired. Okay, so the problem with the yellow one is, if we start with S, we can do the first part, 10, but we have to, when we go to the next part, we have to go to 10B, right? Because A can only go to 0B, or that's actually it. So A can only do one thing. Only has one production. And in S, the starting point, we can only get to 1 by following this production. So we have to go here. Once we arrived here, we have two options. So let me just do both of those. So case 1, we use the terminal, so we get 101 and stop. Or we do 101A. But we need another 1, okay? This fourth bit should be a 1, but there's no production which goes from A to another word that starts with a 1. Okay, so we're stuck here. Okay, and so we cannot produce 10110. Okay, now part B, it says, what is the language generated by G, this phase structure grammar. Okay, and these two examples kind of highlight what happens. Okay, so the starting symbol can either produce 0A or 1A, but once we and so we have to go start with a 0 or 1, and then we go to 0B. We have to do that because there's only one production for A. But once we apply that production for B, we can do one of two things: either stop at 1, or we produce 1A. Every time we produce an A, we have to produce a 0B, and then B is going to either produce 1A or 1. So what is this doing? So this will be all bit strings. Bit strings that start with a 0 or 1, so they can start really with any of the two options, and then produce copies of 0, 1. Okay, however many copies you want, really. So it's really the language, I guess 0. Well, we haven't learned that notation yet, so I'll just stop here. We start with a 0, 1, and then we have to keep producing copies of 0, 1 over and over again. Okay, that's what these three productions do. They just keep continually construct 0, 1s over and over again until we stop at the last one. Okay, so let me know if you have any questions about that. Okay, in this last example, we're going to construct a phase structure grammar to generate this set. So the set is all the bit strings that look like this. We have n copies of 1, and then we end with a 0. Okay, so we have our set G with the grammar consists of this 4 tuple, the vocabulary, terminal symbol, starting symbol, and productions. Okay, so our vocabulary, we have our terminal symbols. We're going to use an A, and then our starting symbol, and then T is the terminal symbol, 0 and 1. Okay, so let's start with the starting symbol, and we want, one way to do this is to work from right to left. So if we end with a 0, then we know we're going to have this, and we want to make as many copies of as 1 as we can, or as we want. We need to make sure every n ones is accounted for. Okay, so we're going to start with this production, and then for A, we want to just keep adding ones. Okay, so A will go to 1A. And then we need to add the production where A goes to the empty string so that we can stop. Okay, if we forget this part, then we don't have any terminal states in here. We just keep producing over and over again. So this A going to the empty string allows us to terminate. Okay, so for these types of questions, there are many different answers. The one that we just worked with, we kind of thought of this as going from right to left. We could also do one going from left to right. So we could create a production set where the starting symbol, this will go to 1A, okay? And then once we're here, we want to be able to keep producing copies of 1, so I'm going to make A go to 1A, and then we can just terminate at 0, okay? We have to make sure that whatever string we produce ends with a 0. So that's going to be the only kind of terminal symbol that I have in my production. Okay, so this allows me to just keep producing as many A's, and then whenever I want to stop, I'll just end with this production here. Okay, and there's probably some other ones that you could do here, but I'll just leave these two for you to think about, and let me know if you have any questions.